Hello there. Today we're going to learn about conditional probability. It's kind of a simple little concept that causes a bit of a thorn in people's side because there's one word that is often missed that kind of gives it away that it's a conditional probability type of question. So, conditional probability is when additional information is known that will reduce the sample space, and the number of favorable outcomes may also change as well. Here's the formula, and I'm going to get to the formula in a minute after I do an example. So in the first example, a card is drawn from a deck of cards. What is the probability that it is a jack if you know that it is a face card? These words right here is what makes this conditional. This is different than just asking what's the probability of drawing a jack from a deck of cards. We're being told that it's a face card. So in this case, the number of outcomes in the sample space is not 52. The number of outcomes in the sample space is 12. There are only 12 face cards. And out of those 12 face cards, 4 of them are a jack. So that's the way this works with conditional probability. So let's start from the beginning. We have two events that we have to consider. The first one is a jack, and the second one is a face card. So let's let J be a jack being drawn. And let's let F be a face card being drawn. Now, the formula for conditional probability is probability of A given B is the number of outcomes that are in both A and B divided by the number of outcomes that are in B. So that would be the number of outcomes that are jacks and face cards divided by the number of cards that are face cards. So what I want to remind you of is that this symbol, which is just a vertical line, stands for given, or it might just use the word if. So it's basically you are being told that this condition is happening. And usually what I start with is whatever the condition is, that's what goes on the bottom, and that's usually what I start with. So how many face cards are there? There are 12 face cards. Now on the top, out of those 12 face cards, how many of them are also jacks? Well, there are 4 jacks that are also face cards. So the number of cards that are jacks and face cards are 4, so that's the 4 jacks. Out of the number of face cards, which is 12, and that works out to 1 over 3 in lowest terms. So the probability is 1 over 3. So there's a basic example. Let's look at some more. So number 2, a card is drawn from a deck of cards. What is the probability that it is a heart if you know that it is a face card? So sometimes they use the word given, sometimes they use the word if you know that it's a face card. So that's your condition. So our two items here is we have hearts and we have face cards. So let's let H be drawing a heart. And let's let F be draw a face card. So the probability that you're going to draw a heart if you know that it's a face card, equals. Now you don't have to write out this whole formula, but if you want, it's the number of cards that are hearts and face cards divided by the number of cards that are face cards. So there's the condition. So that's what goes on the bottom. So on the bottom there are 12 face cards, and on the top the number of cards that are hearts and face cards. So basically out of these 12 face cards, how many of them are also hearts? That would be 3. The Jack, Queen, King of Hearts. So that probability is 3 over 12, which is 1 over 4 in lowest terms. So the probability is 1/4. So these words get tricky, or these questions get tricky, because you have to look for the word given, or you have to look for the word if, or some sort of indication that they are telling you that something is happening. Number 3, what is the probability of rolling a sum of 8 when rolling 2 dice if you know that at least one of the dice was a 3? So we've got two things. We've got a sum of 8, and at least one of the dice was a 3. So let's let S equal rolling a sum of 8. And let's let T be at least one of the dice being a 3. Alright, so the probability that you roll a sum of 8 given that at least one of the dice was a 3 is equal to the number of outcomes that have a sum of 8 and at least one of them being a 3 over the number of outcomes where at least one of the dice is a 3. Once again, that's your condition. So that's what's on the bottom. So on the bottom, how many of these outcomes have at least one of the dice being a 3? Well, that could be a 3 and a 1, a 3 and a 2, a 3 and a 3, a 3 and a 4, a 3 and a 5, 3 and a 6, or the other way. A 1 and a 3, a 2 and a 3, that's already counted. A 4 and a 3, a 5 and a 3, a 6 and a 3. So that works out to 11 outcomes given the condition. Now, out of these outcomes, out of these 11 outcomes, so out of the outcomes that have at least one die being a 3, how many of them also have a sum of 8? So that would be this one and this one. So that would be 2 out of 11. So therefore the probability is 2 out of 11. That's question 3. Question 4 uses what we call a pivot table. And a pivot table shows two different variables, one on the horizontal axis and one on the vertical axis, and it shows how they are related to each other. So you'll learn more about pivot tables next unit, but there are, again, slightly different questions depending on whether it's conditional or not conditional, and you have to look for the words given or the words if to know that it's conditional. So question 4 says, the table below describes the smoking habits of a group of asthma sufferers. If one of the 1,033 people is randomly selected, find the probability that the person is a female non-smoker. Now, there's no word given and there's no word if. So we're not being told that they're a female. They're not being told that they're a non-smoker. So this is not conditional. This is just an and question. So we're just looking for the probability that they are female and a non-smoker. So let's let F be a female chosen. And let's let N be a non-smoker chosen. So this question is just asking for the probability that they are female and a non-smoker. That's how important reading the question is. There's no given, there's no if, so there's no condition. So out of a total of 1,033 people, there are female non-smokers. There's 349. So therefore, the probability is 349 over 1,033. Now, that's sometimes a little hard to visualize what that is. So sometimes you might want to round this to 0.338. That gives you a better idea of what the probability is. If the probability is something like 2 over 11, you've got a general idea of what the percentage might be, but 349 over 1033, so that's approximately 0.338. So if you're going to round it, make sure you put in the therefore sentence approximately 0.338. There's nothing wrong with leaving it as a fraction, but sometimes it's just more meaningful to see it as a decimal or a percent. Now, with question B, we're finding the probability that the person is a female given that they are a non-smoker. So this question is conditional. The word given saying we're telling you that they are a non-smoker. So out of the non-smokers, how many of them are female? So let's let F be a female chosen. And let's let N be a non-smoker chosen. So this is conditional. What's the probability that they're a female given that they're a non-smoker? So now we have a condition. How many people are non-smokers? So up here, there are 733 people that are non-smokers. And how many of those 733 are female and non-smokers? Again, that's 349. So you can leave that as a fraction, or you can round it to a decimal, which is approximately 0.476. So the probability is approximately 0.476. So what you're going to do now is try the examples on this page. You're going to pause the video, try them yourself, and then you're going to come back to the video to check your answers. Don't forget your lit statements, and don't forget your therefore statements. So pause the video, try them, and come back and check. Okay, welcome back to the video. So for question 1, What's the probability of drawing a face card given that it's black? So F is drawing a face, B is drawing a black. Black is the condition. There are 26 black cards, and out of those black cards, 6 of them are face cards, so that is 3 out of 13. Question 2. What's the probability of rolling doubles if you know that the sum was at least 5? So there's your let statements. The sum being at least 5 is the condition, so by looking at the table, you can see that 30 of the sums are at least 5, and out of those 30, 4 of them are doubles, so that works out to 2 out of 15 in lowest terms. Question 3, this is also conditional, so what's the probability that the person survived given that they were in first class? So first class is the condition. There were 325 people in first class, and out of those 325, 203 survived, so that's the probability right there. So if there's any of this that you did not understand, then